Okay, so to introduce our speaker for today, Marisol Barrero is a certified professional ergonomist and has worked for Toyota North America in their production engineering division safety group for 15 years. She currently manages development and integration of safety related technology across their manufacturing operations. She also externally serves on the boards of the Automotive Exoskeleton Group, as well as the ASTM Exoskeleton Center of Excellence. Marisol is a regular speaker at various safety technology focused events. We're very excited today to have Marisol speak to us regarding emerging technologies to enhance safety at Toyota Motor North America. Welcome, Marisol.
Thank you. Can you hear me okay?
I can.
Okay, awesome. Always great to confirm. So good morning, good afternoon, good evening, everybody, depending where you are. So I'm really excited to be here today and talk to you a little bit about what we're using at Toyota. And really just an overall disclaimer to this is, again, I'm not pushing any of these technologies onto you. I'm simply explaining what we're looking at, what we're finding to be of value and how we're proceeding within our organization. Some of these may apply to you, some of these may not. Again, it's really just what we're finding to be useful. My intent here is just, hopefully this can shed light on some of these technologies and certainly we can progress from there as an overall safety entity. Let me advance my slide here. Okay, so Jessica did a great job of introducing me. So my background is ergonomics, and really about 13 years that I've been at Toyota, I've been implementing ergonomics in some sort of capacity. I've always been within the safety organization. Everything from new model development, so making sure that our vehicles meet the standards for ergonomics for production to keep team members safe, to auditing, program development, basically almost all areas of ergonomics. Up until a couple of years ago, I was the regional ergonomics manager. So for all our plants and headquarters across North America. So again, my background is framed in that. I've been lucky enough being in safety for a number of years to really take in addition to being a CPE, take in a lot of other aspects of safety outside of ergonomics as well. Getting that exposure to industrial hygiene, machine and robot safety, really the full gamut of safety operations. So starting out with that, I just wanted to give you a super quick glimpse into our organization. When I say Toyota Motor North America, I'm primarily talking about the manufacturing side of the operations. We're slowly working more and more with the sales and marketing and financial side of things, but it's mostly the manufacturing side that I'll be talking about today. So basically, I'm within the safety group of Toyota, and essentially it's a corporate safety function, as some of you might know it, and we support all our manufacturing plants. So we have 15 across North America. I've listed them there, the majority in the US. We do have some in Canada and some in Mexico as well. So we support them in all aspects, like I noted before, everything from lockout to managing their KPIs around safety, incidents, et cetera, full gamut. Our operations headquarters is located in Plano, Texas. R&D is in Ann Arbor, Michigan, and R&D handles some of the ergonomics for the design of the vehicle. So for example, the cockpit design, et cetera, seat design and such. So we don't dabble in that here in production engineering where I'm at. And then good segue into engineering location, which is Georgetown, Kentucky, where I'm personally based. So just before we get started, just wanted to quickly share our corporate safety statement and policy, which is Toyota Cares, which essentially the Cares is an acronym that stands for compliance, accountability, reporting, excellence, and sustaining. So this really guides a lot of our activity. We have a goal of 0 injuries. And really a lot of what I'm doing now with regards to innovations, and I also have communications as a is another responsibility. But a lot of what we're doing now with regards to safety innovations is really grounded in that E for excellence, which is excellence in safety through innovation and continuous improvement. And this is, I think, a good way to introduce a lot of these different things that I'm going to talk about. Some of them might seem a little far off into the future in terms of application, but the way I really view it, things is with this quote by Arthur C. Clarke, again, Space Odyssey, responsible for that. So the only way of discovering the limits of the possible is to venture a little way past them into the impossible. So, you know, we're testing things as we go along, seeing if they fit, seeing if they don't fit, seeing how we can improve things so that they do fit. So, so just really keep that in mind and keep an open mind with all of these things. This is a safety technology roadmap that I've had in place the last few years. When I was still the ergonomics regional manager when I started dabbling in this, and I started looking at exoskeletons primarily, and that really paved the way to this role that I have now. So it's really interesting. A lot of this stuff is new to everybody, including to me. So it's a very interesting process trying to put this in place as compared to the more established traditional ergonomics discipline. So, so these are some of the things that we wanted to hit in a linear fashion, you know, throughout the last few years. Some of the things that we started working on in 2018 were a little bit more reactive based on some incidents and some issues that we had had with some of our equipment. You can see some of it is about data management and cranes and powered industrial vehicles and such. And then we started getting a little bit more proactive. So particularly in the area of exoskeletons. So trying to explore those technologies and then paving the way for other activity. So exoskeletons and suits and other body regions outside of the shoulder, computer vision, wearable sensors, virtual reality, augmented reality experiences, and then all the way through artificial intelligence and intelligent plant concepts. We are currently compiling a technology roadmap for 2021 and beyond, so the next few years, and that's not ready yet. But it's interesting how it's developing, and it'll look a little bit more complex than this one, which is very linear in fashion. So I wanted to hit some of these items that we're working on today. And my agenda for today to share is it's going to be a lot about exoskeletons because that's where we started and that's a program that we do have implemented. But I also want to share some activity that we have going on with wearable sensors, computer vision, VR, and AI. And again, as I mentioned before, any mention of specific commercial products or services, it's not a direct endorsement by Toyota, and certainly not by NIOSH either. So first, exoskeletons. So some of you may be aware of exoskeletons. I know there's a growing body of evidence for exoskeletons out there. So with regards to shoulder exoskeletons, we currently have more than 500 devices in place across 6 of our North American vehicle assembly plants. And the vehicle assembly plants, that's really where we get the overhead work. So these are difficult operations where you can see some photos there. They're either installing parts or fastening various parts and such on the vehicle as part of their regular work. And it's been implemented as PPE in multiple applications. So paint, body weld, and assembly shops across those 6 plants with the overhead work. We do have some engine plants and some unit plants across North America, but again, those do not have the overhead work. So for us right now, it is required PPE for a process. I'll expand on this image right here a little bit later on, but when do we decide when it is PPE? So for that particular process. So first, the process is flagged by a selection tool. Which is essentially, and I'll cover this in a bit, but it's a mathematical calculation based on the percentage of the cycle time with overhead work postures. So then if the process is flagged, we do some more analysis. So obviously the process has been flagged because there's overhead work. So by overhead work, you know, the hand is above the shoulder for some portion of the job. And we start to looking at different controls that may possibly be feasible other than exoskeleton. So we don't want to jump into putting an exoskeleton on anybody if it's not necessary. But we start assessing different possible controls. But if no other control is feasible in the short term, then we start to consider the exoskeleton more closely. And then we examine to see if the exoskeleton is going to pose any sort of additional safety risk to the process. So an example of a risk that an exoskeleton might pose is, just entanglement with something, or it could be something outside of safety. It could be, for example, it's somehow going to activate the light curtain for the equipment, so the process is going to stop or something like that. So we make sure that the exoskeleton is a good fit and it doesn't pose any additional risk. And then at that point, it's required for the process. And that means for all the team members working the process. So what we've seen with regards to shoulder exoskeleton impact, we didn't just start this yesterday. We started this in 2016. So it's been quite some time exploring this, and it really started as a grassroots effort. So there was no top down, hey, look at exoskeletons or implement this. There were no executives really guiding what we were doing, but it was just hey, this is something that could really be useful for team members in some of these operations where we really can't do anything else. So we can't rotate the vehicle on its side. So what we saw when we started trialing some of the products, the shoulder exoskeletons, as they were the most robust devices at the time. So the ones for the other body regions weren't really as strong. So that's why we started with shoulders. We started seeing really reports of greater comfort using the devices as compared to not, and lower ratings of perceived exertion, or RPE, a term that some of you ergonomists out there might be familiar with. And we actually did do a couple of EMG studies, or electromyography study, to look at muscle fatigue, which I'll talk about in a little bit. But our progression with shoulder exoskeletons, this is really where the vast experience is in. And we started out, again, just being aware of the devices in 2016, and the plan started dabbling with trialing the devices in 2017. We developed a lot of our systems. So we wrote our regional standard, noting that it's required PPE where it's identified and safe to use in 2018. And then really we've been working on just honing the overall standard. So in 2019, it became a requirement at the end of 2019. And in 2020 and beyond, by maintenance, I mean, we're really just trying to maintain the standard that is out there and work with the plants to make sure that it's actually being followed and helping them. So I want to share a little bit of the electromyography study that really paved the way for us to see that these devices would truly be useful with overhead work. So in 2017, we partnered with Iowa State University, Dr. Gillette and Terry Butler from Lean Steps Consulting, to complete this EMG study. The first one looking at specifically the levitate airframe. So in case you're wondering, in our operations right now for the shoulder, we use a mix of the levitate airframe and the Autobach Paxo shoulder exoskeleton. So we've looked at other products, but we've kind of stuck with those two for a variety of reasons. Here you see an image of, I think this is Dr. Gillette. The angle's kind of odd, but he's establishing the maximum voluntary contraction for one of our team members at Canada plant, what I refer to as TMMC. So sorry if I go back in my lingo. So I'll call it Canada plant for all of you. Essentially, that's what an EMG study aims to do. So establish that maximum voluntary contraction for that muscle. In this case, on the right-hand side, he's doing that for the bicep. And then we put exoskeletons on the team members while they do their process, and then we look at their effort as compared to that maximum effort and study that more closely with and without the exoskeleton. So in Canada, so we looked at 10 underbody processes. They were totally different in terms of the amount of time that was actually spent overhead. And again, they're very, very different processes. The only commonality was that they were doing some sort of overhead work. So across the board, and again, the muscles that were examined were the deltoid, the biceps, and the erector spinae. So in these 10 processes, overall, the study found a significant reduction in the percentage of MVIC for the deltoid and the back muscles when wearing the levitate airframe. You can see some numbers there. The bicep was studied and it was a little bit lower, but it wasn't statistically significant. Now, I think it's more interesting when you look at the various processes in a little bit more detail. So we had, again, that figure I gave you earlier was average across the board, but the percentage MVIC was as high as 16% for the deltoid in this task that was called the left-hand absorber job task. However, if you look at PSA, it actually showed an increase in MVIC for that particular process. So in this case, for PSA, the MVIC was actually higher for the deltoid when wearing the exoskeleton. Of course, it didn't show that association for the back, but the key point here that we started seeing is that, you know, we can't really look across the board how we started and we said, hey, we're going to put shoulder exoskeletons on all the processes of overhead work. It really depends on the specifics of the process, even though it is overhead work. So the effectiveness varies by process, which really led us to craft a tool to numerically tell us when to implement. So our process for determination, so there's a second EMG study that we did with Iowa State, and this one was lab-based. And I'm sure they can explain it a lot better than I can. But essentially, we utilize the ACGIH upper limb localized fatigue threshold limit value, which of course is an external tool out there from ACGIH. And we also utilize our internal ergonomics assessment tool, which is a proprietary tool called TIBA, Toyota Ergonomic Burden Assessment, that looks at forces, postures, tack time, you know, the cycle time for the overall process, weights, et cetera. And it really breaks up the process into all these different details. So, so again, they looked at MVC and they mapped out the various postures. So those little posture images that you see there are directly from our tool. So in the tool, you look at a process and you note the number of seconds that the team member is actually in all those different posture codes. So we were able to map out, you know, how this tool actually mapped out to our TIBA. And what this basically means, so an example there, so posture code 8, so if you look at, I'm not sure if you can see my little arrow there, but if you look at posture code 8, so if the duration fatigue limit is 7.5 seconds for a 60-second tack time. So if we have any process that is above 7.5 seconds and it's a 60-second tack time, this process would be flagged. And again, it's just an initial flag. We would need to look a little further to make sure the exoskeleton is appropriate. So this is what our tool looks like. It's very simple. This is information that is already available from the ergonomics assessment. You can sort of filter out from the existing tool. So we're looking at the various posture codes and seeing if any of them exceed that number that has been signaled out by the ACGIH upper limb curve. And then this list that you see here is an actual list of filtered processes from TMMC, our Canada plant, for North Assembly Shop in the chassis section where they do have the overhead work. And this is a list of processes where, oops, sorry, I advanced there, that has been filtered. So essentially, these processes have been flagged for possible exoskeleton implementation. So then I've explained these two items on top. So again, we use that TLV and we use our internal screening tool. And then as I explained earlier, we examine if there are any other feasible controls to put in place, and then we do a safety assessment. And if all of this passes, then the shoulder exoskeleton is required for everybody in the operation. This may sound very far-reaching, but it's really a very small application. So you know, when we go through the board of all the different processes, we're probably talking about, you know, less than 2% of the processes in a plant, or even maybe less than 1%. These plants are huge, would really require an exoskeleton as PPE. So if you walk into one of our plants, it's not something that would stick out at all. So I know there are lots of forums and debates as to whether exoskeletons are PPE or if they're tools or if there's some sort of engineering control as yet undefined. We wanted to call it something without really concern for what is appropriate for others and what it may be called in the future. So we really wanted to put something in place for something that works for us, for Toyota. We labeled it as PP for the shoulder exoskeletons because using the hierarchy of control, the risk is still present. The exoskeleton protects the team member from exposure, and really calling it PP really allows us to focus on what we really want to do. So visualize the need for stronger controls prior to assigning any exoskeleton. For us, at least, it really allowed quick and easy alignment with existing PPE policies. So we actually took the internal respirator standard that we have in place and actually adapted it for exoskeletons. So it was a really good foundation to already have. And the other item is that it allows us to have risk-based decisions. So things are not static. They're ever changing, honestly. They're a little too dynamic. So PPE requirement is based on the process time and overhead work. So that means when a process changes, and it may change every so often, the requirement for PPE may change. So resulting process may require, so a new process may now require, or it may cease to require an exoskeleton. So in case you're interested, so I know I've gotten the question before regarding what do we do if a process changes and all of a sudden exoskeleton is not required. What we do is essentially, assuming there is some overhead work in the process, we actually give the choice to the team members. And particularly our Indiana plant, they've reported that when they've seen such changes, about 50% of the team members choose to retain their device, even though it's not technically a requirement. So it's interesting. I think they're certainly seeing some value. It's a good segue to note the impact. So Indiana, really have to praise them. They've done probably the best job of implementing the exoskeleton standard and being, very consistent. And what they've actually achieved is very commendable. So they've actually had 0 shoulder injuries in the impacted processes since deployment of the unit. So they technically made it a requirement at the end of 2019, but they had team members, here you see some in paint shop, wearing them as early as 2017, 2018. Starting at 2018, they actually saw really 0 shoulder injuries in those processes where they were designated as required PPE. So really kudos to them for showing that. And again, this is really just icing on the cake. We've seen a lot of other positive benefits with better team member feedback, comfort, et cetera, from the devices. So definitely we are not perfect in terms of implementing the exoskeletons in any way, shape, or form. We have a lot of challenges like anything else. We did look last year and throughout this year to understand the causes or the reasons for no implementation, even though the processes had basically been signaled as required exoskeleton process. And the top 4 reasons are noted there. So number 1 reason was dynamic work. I'll talk about what this means. Then number 2 was bending in cabs, so the exoskeleton wasn't compatible. Space constraints and height of reach. Some of these devices basically don't support your arms beyond a certain angle. So if you're completely overhead with your arms outstretched above your head, you may not actually get that benefit. So dynamic work, what does that mean? So dynamic work is that the team members are spending that cumulative time overhead, but they're going up and down a lot. So they're, hopefully you can still see me on camera. So they're basically installing something and they're coming back down, grabbing something, going back up. So that up and down was really uncomfortable for some of the team members because these are passive shoulder devices and they're not, you still feel that a little bit of resistance when you're coming down. So, so that sense made it a little bit uncomfortable. So we're trying to countermeasure that through more on-site plant support. Of course, we haven't really been able to travel this year, which has been really difficult. And we're trying to understand if some exoskeletons are more applicable with certain concerns as compared to others. And we're also trying to do a study with the University of Waterloo in Ontario to understand what is dynamic. How do we define dynamic so that we can put these devices in the processes where they're going to have the most benefit and they're also going to be comfortable and beneficial for team members. So we're just trying to hone the tool that we have in place just through, again, continuous improvement of our operations. So now I want to share a little bit beyond the shoulder. I want to talk about the hands and some of the items we've considered there. So of course, we have repetitive short cycle time jobs. We have MSDs and really, a lot of the areas of the body. So upper extremity being one of them, hands, back, etc. We did a trial of the Bioservo iron hand, which is an active powered hand exoskeleton. It can be worn alone or under the required glove. So there you have the actual Bioservo glove and that upper photo there that is from Bioservo. And the glove assists while performing grip intensive tasks. So this glove may reduce discomfort and injuries from over gripping. The photo that you see in the lower portion is a photo of the actual trial. So we trialed it in body welds in our Kentucky plant. So the team member there is wearing the power pack, which is a backpack, and then he's actually using the glove on his right hand. So it's not the best view of it, but he's using a hoist. And he does some other tightening operations too. So the device looks like this. Essentially, it's got a backpack with a power pack in it, and then it has a cord and an arm strap that innervates that glove. It's one power pack per glove, and then it's got that remote control that the team member can adjust. And it also is offered in a hip pack now. So again, this is an old photo. Bioservo has made updates to their product, which I do not have pictures of, but it is an ever-evolving tool. How does it work? Essentially, it calculates the force that needs to be applied by the hand and assists the user by adding a portion of that force. So essentially, the force that's required to perform the operation doesn't change, but biomechanically, the person is applying less force because the glove is applying a portion of it. So that's basically how to frame this. In our Kentucky plant, we had 8 team members. They trialed for 10 days in fall of 2019, and they wore a cut-resistant glove or the iron hand glove, as it is a required form of PPE and weld shop due to the high laceration risk from those sharp stamped steel panels. So the results, I should also mention the iron hand glove does a digital assessment of the hand activity level, which is another external tool through ACGIH. And so here you have a bar chart that's noting with and without the glove in terms of that hand activity level. For anyone who's not familiar with the hand activity level, you see the scale there, but it's basically looking at hand exertion, risk of hand injury from motion and burden. So what we found a statistically significant difference between using the iron hand and not using the iron hand. And in some cases, using iron hand actually put the team member below the action level, the action limit, excuse me, that the hand activity level generates. So numerically, it looked really good in terms of reducing exertion. Now the feedback, and of course, team member feedback is extremely important, and whatever we do, if we decide to go any further with these devices or not, as I hope I explained with the shoulder devices. So in the case of the iron hand, the team members identified value in using iron hand, but had pretty significant concerns with regards to comfort. So one of them being the weight of the power pack. Another big one being the wearing of 2 gloves. So the iron hand couldn't be used in this particular shop because it's not cut resistant. So having the 2 gloves made it difficult to manipulate small parts, and then impacted tactile feedback. So in some operations, you do have to perform some flushness checks or see if there's any burr or anything in the panel, and this was impacted by that particular device. At the time, there were some issues with the quality of the sensors. So some fingers would stick, some would not activate, which I believe is a problem that has been teased out by Bioservo at this point in time. But again, you have that negative feedback from the team members. So coming out of that, and this is completely open to discussion within and where we go from here, but coming out of that very small localized trial, this was our process decision flowchart should we ever implement this product in our operation. So we would look for processes that are high risk for hand MSD as per our internal tool, TIVA, that I talked about earlier. Processes that use some sort of jig or tool, so essentially a high force power grip for more than 60% of the cycle time, where it doesn't have a tactile check or small part manipulation required with the gloved hands, and no other control is feasible. So same as shoulder exoskeletons. And also we would need to make sure that the device doesn't pose a safety risk of any type. So, but again, we're planning to do another trial to try to hone this process selection chart. So the next steps, so Bioservo has made, as I alluded to earlier, many positive changes to their product. We tried to do a trial in 2020. Of course, COVID came along and it was really hard to do anything. So, so we're planning to do a more in-depth trial for several processes in May, again, in our Kentucky plant. And we're actually going to be doing an additional EMG study to independently confirm the reduction of effort. So we're not going to just be looking at the hand activity level that is being provided by the Bioservo. We're going to have an add-on EMG study. So for the back, just checking on time here. So I got about 13 minutes. So for the back, we certainly have some operations where we could implement some back devices. So we have some operations that are lifting related, or where they're engaged in static trunk flexion. So we are examining these pretty closely as we have been able to do in 2020, with, again, the challenge of traveling, having vendors on site, COVID, et cetera. We did trial 2 devices early on, and they were exoskeletons. They were rigid frames for the back, and they were very mini trials, very informal trials, as in, hey, what do you think of this product? And the feedback was not that great. So basically, there was a long time to don and doff. So which is basically putting on, taking off. And they were uncomfortable because of our rigid devices. They were difficult to move in. Some team members reported, just pressure on the chest area, which is particularly uncomfortable for our female team members. And we didn't really go much further. So, but it's very exciting now, because the images you see here are of very different devices that are emerging these days. So what you see on the upper right-hand portion is HeroWear. That is a back exoskeleton or exosuit that's really focusing on diversity and women, being able to fit women. So, which is really exciting. And then the Ottobock Paxo, and then Seismic, which the concept is, clothing or an undergarment. So basically we're going towards the exosuit route as compared to the exoskeleton, which is more rigid. And I really believe that for back, that ease of movement will be really necessary for these items to be more easily accepted by people to wear. So that is it on exoskeletons. Again, that's really the majority of our work, but we're doing a lot of things in other areas. So wearable sensors, just jumping right into this. So we trialed something that we feel is really useful. We're in the process of planning for a wider scale implementation. So we trialed the strong arm fuse in 2019. And what is the strong arm fuse? So in the photo here, you see the team member wearing the harness, and then the sensor itself, which is that rectangular device on the torso area. So it's a body-worn sensor that uses machine learning to capture and analyze trunk movements to develop a safety score. So if any of you are familiar with the lumbar motion monitor from Ohio State, Dr. Bill Maris, so it's not to say this is exactly that, but it's using a lot of the concepts from the LMM to guide toward greater safety and lifting. In addition to establishing a risk score, this sensor is capable of giving haptic feedback, or a buzz, when the team member engages in high risk exertions that are set within certain parameters to encourage people to improve their lifting techniques. The reason we're looking at it at Toyota is certainly to reduce injuries for conveyance team members, improve comfort, reduce risk in general, and also to reduce the amount of time to complete these risk assessments. So we're looking at this for small lot delivery operations. Our current tool that we utilize for these assessments takes about 6 hours to complete per process. And it's probably done maybe 2 to 3 times each year per route. we have about 1,000 routes across all North America. So if you do all that math, it takes a lot of time to do these assessments. As important as they are, we can do these in some other more automated fashion and really focus people's thinking and skills on implementing controls to reduce risk. That's really where we want to use that people time. So how this works. So you see a couple of images there. So at the start of the shift, you put on your harness and you go to the device there. You go through the screen. It pretty much looks like an iPad. You scroll down, you find your name, you click on your name, and a sensor lights up in blue, and that is the one that you're going to be using for your shift. Throughout the shift, the sensor automatically collects the data. And at the end of the day, you dock the sensor back into that docking station to charge and to obtain your personal safety score. So essentially you get a score from 0 to 100. And it's framed from athlete's perspective. So what that means is that the higher it is, the better you did. So it's not framed in the traditional risk element. So the higher the number, the higher the risk. So it's really framed from your point of view as in the worker. What we saw in the Indiana trial, we used this device for 2 months. So 1 month was just to establish baseline condition for team members. And then after 1 month, we actually turned on the haptics for 120 team members. We saw 95% reduction in time to complete the risk assessments. Of course, it's not a surprise. So we're manually entering information as compared to using a sensor to automatically collect, excuse me. But the very exciting thing is that we saw 83% of team members improve their lifting techniques from the haptics alone. So as measured by the device. So again, so that is definitely very exciting. So we didn't really have time to do much else. It was only a month. We didn't implement any controls onto the route, which is something, of course, we would like to do additionally. But only from the haptics, we saw that improvement, which is really great. And then overall, we saw 15% risk reduction by the end of the trial. Really, I call this a game changer for us. It's a very interesting new paradigm. So the assessment tool is itself a control in offering that haptic feedback, which is really something we've never seen before, the union of those two items, assessment tool and control. It introduced gamification into the process. So we commonly heard the team members talk about, hey, what's your score? Hey, I did better than you, and kind of that friendly competition. This image here is really one of the things that's greatly won me over. So, so it really supplements the process score with a personalized assessment. So the FN3A is the name of the conveyance route. And traditionally, our assessment tool, you would have a single score. Just, hey, here's the route. It's yellow, medium risk, or low risk, whatever it is. Here with the sensor, we now have the ability to look at different people and how different people are moving and who's at possibly higher risk of injury. So the thought here is that we can work with those folks that are at higher risk, really coach them to lift better, of course, also change the workstations and such, but we can do a lot more one-on-one coaching, whereas before you had a single process assessment and you were assuming that everybody was doing the same way. But that's not actually the case once you start examining everybody. So yeah, there were some early concerns about monitoring and data usage, which basically went away throughout the trial. So StrongArm does have a safety pledge that you must not utilize fuse for punitive measures. So it's really just about improving safety. There were some concerns from the harness and, of course, female concerns about the location of this sensor on the chest. And then we really need to understand more data to see if it actually does reduce injuries, right? It reduces risk, but does that equate to reducing injuries as well? And it was too short a time to really assess this. It was only 1 month of haptics. And again, how long do we wear this? And what happens when you remove the sensor? How quickly does that good new lifting behavior extinguish itself, right? We know that from operant conditioning. If any of you are familiar, once you take away that feedback, the behavior typically extinguishes itself over a period of time. We are looking at some other sensors as well. So outside of StrongArm Fuse, we're looking at a company called Life Booster, and then you see that lower right-hand image, that is a Life Booster. So essentially you wear actual sensors on your body. I believe you wear 5 and you get different posture angles. We're trialing a watch that is called GoX, and that's looking at energy expenditure. So it's looking at your oxygen consumption and heart rate. So we're trying to see if all these different variables can be utilized in our environments for something. If they're actually useful, they can complement the traditional ergonomics assessments. And we're also researching industrial hygiene type of applicabilities. So we do have some casting plants where heat is a concern. So we're looking at heat stress. What we're starting to see is that a lot of these wearable sensor devices that primarily have the ergonomics purpose, they're starting to build in some of these more industrial hygiene monitoring aspects. So it'll be interesting to see how that goes in the future. Computer vision, I'm going to start being pretty quick here because I wanted to cover this pretty lightly, but computer vision we're looking at as well. So computer vision, essentially what that is, allows computers to get an understanding from digital images. Sorry, I can't see my screen here. That basically to automate tasks that human vision would traditionally perform. So we've been working, this video, oops, sorry. The video does not, oh, here it is, I have to play it. Huh, it does not play. Okay, well, essentially this would be somebody moving and you would see all these markers moving around with her, and you have an image there of what that would look, and that would be a moving image. But basically computer vision, you would not have to wear any sensors on the body, so the team member would be completely free of sensors. And just by using my phone, I'd be able to capture some video and it would automatically calculate all the posture angles. So that's another possibility of looking at how we can automate a lot of these very lengthy risk assessments and make them more personalized for individual team members as compared to having that single process score. So we're studying that. We're also starting to look at some other areas outside of ergonomics. So we started out with ergonomics, but we're looking at some possible safety implementations. So some of our engineering groups are starting to use computer vision for quality inspections, seeing if standardized work is being followed. So we're trying to tap into some of those aspects. So for example, computer vision could see is the team member wearing the appropriate PPE for the process? Is the team member trained and certified to use a particular tool, et cetera? So we're trying to expand outside of ergonomics as well for computer vision. We're looking at virtual reality as well. Virtual reality, so the background for this, so our acute injuries. So these are things like lacerations, slips, trips, and falls, et cetera. So again, this is outside the realm of ergonomics. Our top root causes for acute incidents are the ones listed here: incorrect method followed, lack of awareness, and improper training. So we're trying to utilize virtual reality to enhance our safety training. So basically the theory is that you retain based on your level of involvement. So what we've done traditionally is focus on passive training techniques. So basically an e-learning or a video or an instructor-led training, we haven't really put people right then and there to experience things. So we're trying to do that through virtual reality. We're focusing on, initially, at least, anything can benefit from virtual reality, but ergonomics here is not really our top priority for the time being. So we're looking at high-risk tasks that are difficult to simulate where high retention is crucial. So we're looking at those more acute, very high-risk incidents, so possibly lockout, cranes with heavy overhead loads, electrical safe work, power industrial vehicles, et cetera. It's very exciting. So the world of VR is becoming more and more interesting. So there are emerging accessories that, again, are going to really provide a whole other aspect to VR. So here you see a couple of examples. Both of these are going to add additional dimensions other than the visual to VR. So that VR glove that I have pictured there, it acts tactile feedback. The Tesla suit on the right-hand side, and there's no relation to Tesla, the auto company, it just happens to be the same name. So it's going to use electrical muscle stimulation to make you feel pressure, vibration, weight, heat, cold. Really exciting, the things that we could do with VR training with helping training retention. There is a different group that is examining digital assembly and virtual reality very closely. We are not doing that at this moment in time, but they're looking overall how to use VR to build a vehicle. So the images that you see are of the traditional program that we use to see how we can build the car safely and ergonomically. And we put a mannequin in place there to see how different things are going to be done, but we're not experiencing them directly. So we're hoping to enhance that through VR as well. And we're trying to understand how to use VR in a manufacturing environment. So, you know, on the lower half of the page, you see somebody gaming at home. On the upper side, you see a Toyota plant. So again, it's very different, the concerns that pop up in terms of how to do this. So a significant concern, I don't know if, again, if you're aware, is cyber sickness. So essentially that's motion sickness that's induced by virtual reality. Some of us are more sensitive than others. And so we're trying to understand how do we compile these VR training enhancements without actually giving people motion sickness. As you could imagine, they'd have to go back and work on the line after. So we're definitely very concerned about their safety. And the last bit that I will touch on, because I'm running out of time, is artificial intelligence. Artificial intelligence, I'll quickly define it. It's the theory and development of computer systems able to perform tasks that normally require human intelligence. So I think this is a really good way to frame what AI is. So this is from AI Summit. I'm not an AI expert, but essentially how they explain it is that, you know, first it was, you know, essentially paper and ink. Humans were not optional. And we are really primarily in the age of software. So where tasks can be automated. So repetitive and prescribed tasks can be automated without humans, and we program software. The AI realm is really going to be where human reasoning begins to be automated, and we coexist with machines, and we do not program it. We actually train AI to help us. Some daily examples of AI you may be familiar are listed there, Siri, Amazon, etc. Retail industry is a huge user of AI. So I think I read a figure like 30-something% of Amazon.com purchases are actually generated through suggestion engines based on previous purchasing behavior. So retail industry is a huge early adopter of AI. And this is the growth of AI here. So again, it's currently evolving. Retail is the one primarily using it. In the next 10 years, some experts say that, again, is not from me. This is from experts at a conference that I attended called AI Summit, if anyone's interested. It's going to be growing in targeted applications, medical and legal. And then, you know, 10 years beyond, it's going to be more human mimicry. So machines are going to behave and sound more like humans. And then beyond that, they claim human consciousness, which might be a little scary thought. Hopefully it's not the age of the machines, but that is the progression. So basically, how do we tap into this? How can we use artificial intelligence to assist with reducing injuries? Our plants, I don't have any images to show you here. A lot of it has to do with incidents, which I can't show. But essentially, we do a lot of prioritization and risk prediction based on things that have happened in the past, not just risk assessments, but also where have injuries occurred. So we do that manually now. People spend a lot of time on this. So we're trying to understand how artificial intelligence can help us make those connections a lot faster by joining different information, which was maybe previously siloed. And then this is really my last slide here, so I'm a little bit over, but I've showed you a lot of different things that are maybe don't all go together right now. And this is a really big question that we have. So technology ecosystem, how do we effectively create this? So ecosystem being, how do these things all live together? So we don't want to put 50 devices on people. So how do we build this as an ecosystem where all these different facets have value and can coexist naturally and comfortably for people and really get the utmost benefit? So I know that was a whirlwind. I talked really fast towards the end. So I really appreciate your interest and attention in this, and feel free to connect with us. If I don't get to answer your question within the seminar, I'm happy to connect further through those methods noted there. That's all I got. Thanks.
Thank you, Marisol. I had unmuted Brent, but I'm not sure exactly where. Let's see. Maybe I lost him.
He looks like he's mute. He's muted.
Let's see if we can do this.
Can you hear me?
There we go.
Okay, thank you,
Hi,
Jessica.
Brent.
Thank you, Marisol, for a great presentation. And with respect to time, we're going to segue into some of the questions that were posed. So I apologize if your name shows up in the chat box. I will use your name. If not, or I can't differentiate, I'm going to use your username that was provided. But Marisol, we had a question from Chris Reed, and he just wanted to know if you could explain why Toyota would make some areas or types of work mandatory and other areas voluntary, and were there any qualitative or quantitative reasons for that reasoning?
So why required in some areas? I think it just has to do with the level of risk. So everybody's familiar with other types of PPE, or most people are. So in terms of, safety glasses, safety shoes, hard hats, respirators, et cetera, anti-vibration gloves, et cetera. Where we see that risk being there, so in this case, the overhead work or some other possible risk in the future outside of that. If we see that risk, that can be effectively reduced with a new device, and it doesn't pose other significant concerns of comfort, other safety issues, et cetera. Again, it's really in the world of safety, it's for us, it's really, or for me, speaking for myself, it's almost a moral responsibility to really provide that and have people use it. So, so again, we're trying to make it so that everything is as comfortable as possible. But I assure you that most people also do not like to wear safety shoes, safety glasses, hard hats, et cetera. These days, most people don't like to wear face coverings either for COVID. But again, it's things that we do that will provide us with greater safety. So, and that's why we require it, just the same as all those other devices. With regard to the voluntary issue, we have found some team members that truly just want to use it, even though we haven't seen such high risk. They're really interested in using it, and we're making that an option for them. So a lot of people look across the line and see somebody else using the device, and where it may not be required in their process, but if they see value and they feel value, we want to be able to provide that as well, even though it's not required. So that would be the differentiation. Hopefully that makes sense.
Okay, thanks. We had a question from Jake, and he was just wondering what was the decision that led you to try the product with the harness, and if there were any pros or cons with respect to the harness versus different products.
Yeah, that's a great question. So there are other sensors out there, certainly. So this particular one from StrongArm Fuse, I think they've done a great job in being able to provide the information in a very simple manner to the team members who may not have a strong safety or ergonomics background. Their sensor collects a lot of data, but then compiles that through their proprietary algorithm that I don't have it either, and it gives you a single score that anybody who's ever taken a test in school or ever has gotten a grade can relate to, 0 to 100. It's telling me how I'm doing. So just that aspect of it really resonated. It's just having it be really simple for folks to understand, not just safety professionals. So that made it really attractive. The harness was a concern, as I understand it. StrongArm is actually developing different ways of tethering that sensor to the body, including a backpack. So when we do a trial, hopefully soon in 2021 at our Indiana plant, we will be giving team members the option of utilizing that device however they want to use it. And I think they're working on other, not to speak for StrongArm, I think they're looking at other possibilities of having that sensor on the body, such as even like a t-shirt with a pocket, things of that sort.
Sounds great. So another question from VX609D. The question is, how was or is the employee's response to the required PPE?
Yeah, I mean, I'd definitely be lying if I said everybody's like incredibly happy about it, right? So we had similar responses to, again, face coverings, other PPE. I think the plants have done an incredible job of communication. You know, if you just come out and say, hey, you know, next week we're going to make this required, and you know, that's that. That sort of thing does not work. So it's a very long process where you start sharing the information. The why is so important. The why of what you're doing something is so critical, and how it's put together, that communication piece. So really showing, right, we're concerned about the safety. We really want to improve these operations. We realize we can't improve it in all these other ways. So we want to do this. And really that communication is really important. So I think a lot of folks that had concerns early on have come around. There are some that, you know, maybe don't accept it and maybe just put it on because they have to and are maybe not so happy. But again, that happens with all PPE. So we're really concerned about safety while we still work on making things as comfortable as possible for everybody.
Sure thing. So next question from SATYAJIT. They were wondering if it took any time to get used to the exoskeleton, and how did you train employees using the exoskeleton? And if so, how was the training performed?
Yeah, so another really good question. So again, our plants, I'm really sort of the voice in this level for a lot of our amazing plant safety professionals that really do this hands-on, but it's about the introduction again. So there's a ramp up. There's a whole schedule that we have in place with introducing these devices. So let's say there's a new model change and there's a you know, set of new processes. The assessment is done and the assessment is flagged, and we go through the process to designate it as a required exoskeleton process. There's the whole, you know, communication, speaking to the team members, introducing the device, fitting them appropriately, and then there's a ramp up process. So when they start wearing it, you know, they only wear it for a very short time, the first week. Then the next week they ramp up a little bit more and they start wearing it a little bit more, you know, hours per day. So again, it's a very long introduction process. That whole time they have to be refitting, addressing the team members' concerns. Hey, you know, I need to kind of adjust this buckle. I need to maybe lower the resistance, et cetera. So it's a long process. And that's why it's, you know, if you're just gonna take these devices and kind of, hey, you're all wearing this because, you know, we saw Toyota had really good impact. That really doesn't work. It's a whole program that goes along with it, like anything else.
Thank you. So from Jake, he had a question and asked about the future application for VR training to prevent slip, trips, and falls. What do you think?
Yeah, whoever that is, if you have some ideas, I'd love to see that. So slips, trips, and falls are a big issue that we have across Toyota, like in anywhere else, I think. Lots of manufacturing. So I'd love to hear some ideas. So we are developing a safety critical eye training in VR that will help team members spot hazards more easily. Slips, trips, and falls for us, I mean, they occur for, the main reason is 5S, which again, it's basically having a very clean and orderly environment. So some, you know, parts that shouldn't be on the floor somehow get on the floor. You know, something gets on the floor that shouldn't be, some sort of spillage, et cetera. So being able to spot all those things more easily, that'll definitely foster less slips, trips, and falls.
Sounds great. So the last question that we probably have time for is from Jeff Hoyle, and he just was wondering, how do you handle the sanitation and the cleaning of the exoskeletons?
Yeah, so this past year, we didn't actually see an impact from COVID for the exoskeletons that were already in place. So basically, each team member gets his or her own device that is not shared. So they would clean it just as they would normally clean it with an antibacterial wipe, et cetera. Some of our sites do have some devices that clean through ozone, such as our Indiana plant, and they do effective sanitization through that. We haven't seen an impact there. well, we have seen an impact. We're trying to get new things in and such. So with a lot of our trials, like VR, that's probably as you can imagine, putting a headset on is a very significant risk of COVID. So we've developed a pretty rigorous protocol requiring PPE to be worn. So for example, those, I forgot what they're called right now, but basically they're little eye masks that protect you from the device, and of course, alcohol wipes, etc. Using even hairnets and gloves while using the devices. And in addition, we've invested in some devices. They're called a clean box. It's essentially a way of sanitizing the headsets through UV light. So we're doing that as well, in addition to all the other protocols. So it's been challenging to do new things due to COVID for sure. We're still trying to go on. Again, the injuries are not going to stop just because there's COVID. So we really need to look at these promising options to help us in that realm.
We actually do have two more questions, quick questions. So Ryan Porto asked, are you having more success with implementation with the sensors or computer vision in general?
So yeah, so I was really hoping, Ryan, I was really hoping that computer vision was going to be the key to everything. So it sounds wonderful. You don't need to put anything on anybody. You just film and go, and there's your information, right? It is proving more challenging than sensors because a key item that we've had is really developing the infrastructure to be able to process that info. Super data heavy. We've had to set up servers to actually be able to process that information, which is very complicated and such, to store and hold that information, interpret it accordingly. So we're really going to see how this comes out, and if it's something that we want to pursue further in that area. But right now, the sensors are a lot easier. Now, of course, there's some cons to them, right? People have to wear things, right? Being the number one, right? So again, it'll be interesting to see, and I think time will tell how we can integrate maybe the two items, or really just choose one over another until maybe computer vision works a little bit better, or we can make it work a little bit better.
Thank you. So the last question is from JGB513. Was there an opportunity to determine ROI related to lost cost and production improvements when adopting the various technologies?
Yeah. So I'll note the strong arm fuse sensor as a key example. So the reason we're implementing it at our Indiana plant as soon as it's okay to do so based on COVID this in 2021. So we actually, again, in terms of applying these things, you have to really look at the dollar amount for everything. So we were able to look at the injuries that we have had in those areas and the possible improvements based on the risk reduction that we saw in the trial. We were able to put a number to that. So again, it's about people, it's about safety, but again, it's a lot of it has to do with cost, right? To do certain things, we were able to do that. And then we were also able to do, look at the current time that it takes to do the ergo assessment. So those things are done by folks at the plant. So it's their time and effort that it takes to complete those ergonomics assessments. And again, we were able to put a dollar value on that. Of course, these devices are not cheap, right? So, so you have to do that return. But in that particular instance, we were able to see a good return from using those devices. But, again, you have to compile all your numbers. Sometimes it's not about ROI. I know we always make it about ROI, but sometimes it's just really about improvements and hand safety. So if you're in the safety realm, I'm sure you have a lot of operations that are not giving you any ROI, particularly in the acute incident side. But it's things we do because, again, it's in the interest of safety, or there's compliance around it, et cetera. So it's not all about ROI.
Absolutely. And thank you for a great presentation that completed the Q&A session.